In this video, we carry on with differentiation from first principles. Now remember, the derivative function is a function f dash of x which allows us to calculate the gradient of the curve y equals to f of x at any point along its length. When we have f dash of x, all we need to do is replace the x by the x-coordinate of the point at which we want to calculate the gradient, and we're done. It'll return the gradient. But so how do we actually find the derivative function? Well, remember, the definition of the derivative is the following. F dash of x equals to the limit as h tends towards 0 of f of x plus h minus f of x over h. So, in this video, we're going to work through a couple of examples which show how to actually use this formula to find the derivative of a function. Let's get started. As a first example, let's see how to differentiate f of x equals to x squared from first principles. Now remember, the formula for differentiating from first principles is the following. F dash of x, the derivative, equals to the limit as h tends towards 0 of f of x plus h minus f of x over h. So let's see how to do this. Well, first of all, f of x plus h is equal to the following. We have f of x, which is x squared, so f of x plus h would be x plus h squared. And that's equal to x squared plus 2xh plus h squared. So replacing this inside our formula, we have f dash of x equals to the limit as h tends towards 0 of x squared plus 2xh plus h squared minus f of x, which was x squared, all of which is over h. We now simplify this a bit. We can see that the x squares cancel out, so we're now left with the limit as h tends towards 0 of 2xh plus h squared over h. And we can simplify this a little further. This equals to the limit as h tends towards 0 of, every term has an h, so we can get rid of that. So that's 2x plus h. And now when h tends towards 0, this h here will also tend towards 0. And so in the limit, as h tends towards 0, we have the derivative f dash of x equals to 2x. In other words, once h tends towards 0, we're only left with the 2x, and that's the derivative. The derivative of f of x equals to x squared is f dash of x equals to 2x. Let's look at another example. Let's say we have to differentiate from first principles f of x equals to 2x cubed. Well, again, our starting point is the same. We start with our formula. We know that f dash of x equals to the limit as h tends towards 0 of f of x plus h minus f of x over h. And in this case, let's work out what f of x plus h would be. We have f of x plus h equals to 2 times x cubed, so that would be x plus h cubed. And now x plus h cubed is equal to the following. That would be 2 times x cubed plus 3x squared times h plus 3xh squared plus h cubed. And now, distributing the 2 across, we have f of x plus h equals to 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed. Now that we've done that, we just need to plug this back into our formula. So f dash of x equals to the limit as h tends towards 0 of f of x plus h, and we've just seen that's 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed minus 2x cubed over h. We can see that the 2x cubeds cancel out, and so we're left with the limit as h tends towards 0 of 6x squared h plus 6xh squared plus 2h cubed over h. Dividing each term by h, we now have the limit, as h tends towards 0, of 6x squared plus 6xh plus 2h squared. And now when h tends towards 0, each of these two terms will tend towards 0. And so we're going to be left with the only term without an h, and that would lead to f dash of x equals to 6x squared. And there we have it. That's how we differentiate functions from first principles. I hope that helps.